Hello everyone, this is a quick and dirty Graham's Law of Effusion. Looking at the rate of M2 over M1, this may not mean much to you, so to start with, we'll make it real. Have you ever wondered why a porta-john would smell worse in the summer than in the winter? Or that actually has to deal more with kinetic molecular theory, but there's certain gases that are heavier than others. Just like when I tell my students that in college I ran a 4:35 mile, but just last week I ran like a 9-minute mile. Why has Coach Key gotten so much slower? Age or weight? It has more to do with weight. So that always means who's going to be faster, Mr. Key skinny or Mr. Key in the current shape? So obviously he was much faster when he was smaller. So that kind of tells you the first part of this problem. Who's going to be faster between these gases? So one thing that I have students write in on their formula is that the heavy one is always on top of the light one. So if you do that division first and then take the square root, you'll have the rate of how many times faster that lighter gas is. Let's try one and hopefully it'll make more sense to you. So looking at the practice problems down here, helium versus argon. So which one is faster, helium or argon? Well, we go to our periodic table and we find that helium weighs approximately 4 grams. And argon weighs approximately 40 grams. So now, using our formula at the top, who's on top? The heavy one. So we're going to do the square root. I'm going to use a parenthesis here, just to remind me to do this math first. So we're going to say, to simplify that, square root of 10, and that should be like approximately 3.16. Now, if this is grams and this is grams, the grams cancel. So what will be our unit here? Well, it's really not 1, but it's like 3.16 times faster is what I like for students to write in. So which one again is the lighter one or the faster one? Helium, because it only weighs 4 grams. Okay, let's try another one. Hydrogen gas versus sulfur dioxide. So very quickly, we'll say 2 times 1 approximately is 2 grams, and 32 and 16 times 2 is also 32. So 64 grams. I'll just find the molar mass there in my head. So we can quickly, again, set this up. Square root of the heavy one over the light one. And that's just simply the square root of 32. Which should be approximately 5.66 times faster. So hydrogen is 5.66 times faster than sulfur dioxide. Okay, our last problem here is oxygen versus helium. 32 grams, which is the 16 times 2, and we've already looked that one up to be 4 grams. So again, that all came from the periodic table. Do our radical, and then we'll say the heavy one over the light one. And of course that is the square root of 8, which is approximately 2.83 times faster. Now who was faster there? Helium. Alright, hope you enjoyed that. Feel free to review and see that again if you need to.